enough that you hear me and see the board okay? All right, here we go, guys. Happy Friday. Only a few more weeks left, guys. We are going to continue in section 6.2 with our inverse functions. So I kind of just put a review up here as to what we want to remember about an inverse function. Remember, it is going to be a function that undoes what another function is doing. If x goes into the original function and y comes out, then that means the point xy is on the graph of the original function. But then the inverse is going to undo everything that function did. So it's going to take this output as its own input to start that undoing process. So now y goes into the inverse function and it spits out the original x that you started with. And you're right back to the beginning, okay? Therefore, the point yx is on the inverse function's graph. So really what the inverse function is doing is it's reversing all of your original function's ordered pairs, right? So if 914 went on this function, then 14,9 would be on this function's graph. X and Y literally trade roles. And then we saw if we want to create an actual equation that undoes another equation, right? Then we had to take the first equation, switch its X and Y values, and then resolve it for Y. And that's how you can literally write the inverse function's equation. All right, so what I want to work on today is when you're looking at two functions, how you can tell whether or not they're inverses of one another, all right? So guys, look at example 1. I said, given the function f of x equals x plus 3, and the function g of x equals x minus 3. Well, I hope you guys remember from yesterday that we saw that this function and this function are inverses, right? If this function is going to add 3 to its input, and then this function is going to minus 3 from its input, that's going to undo everything he did. So these are inverse functions. So what I want you to see, watch what happens when you compose inverse functions. When you plug one function into its inverse, watch what happens. All right? So guys, let's find f of g of x. So remember, x is going into g, but he already lives there. So now we're taking the entire g of x function and we're plugging it into function f. So really we're finding f of, who was the g of x function? He was x minus 3. So we need to go to function f and plug x minus 3 in. All right, so go to function f and start rewriting. Guys, it starts with an x. Take that x out and put x minus 3 in. So it's going to be x minus 3, and then there's still a plus 3. Well, now when you go to clean this up, watch what happens to a negative 3 and a plus 3. They cancel. You're just left with x, which was the original input that you started with. Because if these are inverses, their operations are opposite. They undo one another. So when you plug an inverse into its a function into its inverse, they're going to cancel all the operations out, and it's just going to leave you with x. So if you can prove that when you plug this function into that function and all the operations cancel out, then you're basically saying, hey, these are inverses. Their operations are canceling everything out, all right? But it has to work both ways. You have to be able to plug this one into that and everything cancels, and you also have to be plugging this function into this one and everything cancels. It has to go both ways where all operations cancel. So let's see what happens if I find g of f of x. So now I'm plugging x into f, but he already lives there, so we're fine. So now I have to take the entire f of x function and plug it into g. So that would be g of, who was the f of x function? It was x plus 3. So guys, here's your roadmap. You got to go to function g, and you got to plug x plus 3 in. So we're going to function g. It starts with an x. You got to plug that in. So take this x out and put x plus 3 in. And then finish it off with the minus 3. And then yet again, when you go to clean this up, the positive 3 and the negative 3 cancel, and you're just left with x. So again, if you plug a function into its inverse, all operations cancel, and you're just left with x. So if they ever show you two functions and they're like, are these functions inverses? This is one way to prove that. If you can plug them into each other and all the operations cancel out, then you are proving they are inverses. You are proving that they contain all inverse operations. All right, so there we go. So guys, to verify inverse functions, which means that you want to prove that two functions are inverses. One way to prove that will be to show that it undoes the other function, is to prove that when you plug them into each other, everything cancels out. So therefore, you must prove that the composition of each function is equal to x. That's how we are supposed to verify that two functions are inverses. We got to prove that when you plug each function into each other, they both end up equaling x, that all operations cancel out. All right, so that's what we want to practice today. We want to practice verifying inverses. So we have to do a lot of compositions again, a lot of f of g of x and g of f of x. All right, let's go to the first example. All right, well, we're given the function f of x equals 3x plus 9, and we're given the function g of x equals 1/3 x minus 3. They want us to verify whether each pair of functions are inverses. So guys, to do that, we're supposed to prove that f of g of x equals g of f of x, and they both end up equaling x. Right, normally when you plug one function into another and then you go the opposite way, it doesn't leave you with the same function. You get a different answer usually when you find f of g or g of f. But because we're trying to test for inverses, hopefully a lot of them will be equal to the same thing, and that'll be x. All right, it doesn't matter which one you find first. I just naturally go for f of g of x. All right, so here we go. Let's see. When we plug g into f, does everything cancel out? All right, x is going into g, but he's already there. So let's take g of x and let's plug it into function f. So we're really finding f of g of x was 1/3 x minus 3. All right, here we go. So we're going to f and we're plugging this in. So go to f. It starts with a 3. Give yourself a 3. Then it has an x. Take this x out and plug that in for it. So now it's going to be times 1/3 x minus 3. And then don't forget to finish it with the plus 9. So we did it. We plugged g into f. Let's get rid of our parentheses and let's combine like terms. So guys, 3 times 1/3 is 1. That's 1x. 3 times negative 3 is negative 9. And then bring down the plus 9. What happens to minus 9 and plus 9? They cancel, and you're just left with x. So that worked. Now, guys, you can't be like, oh, okay, they're inverses. You always have to check both ways, because maybe when you plug g into f, everything cancels and you get x. But when you plug f into g, maybe everything doesn't cancel. So you have to prove that both of them. So you have to do both compositions. All right, do the next one. So now we're going to find g of f of x. Now we got to plug f into g. Go the other way. All right? So x is going into f, but that already happened. So now we're taking the entire f of x function and we're plugging it into g. So that means we got to find g of f of x is 3x plus 9. All right, so this is our roadmap. We're going to function g and we're plugging in 3x plus 9. So guys, go to function g and start rewriting. All right, so we got 1/3. Give yourself a 1/3. Then it has an x. That x is coming out, and 3x plus 9 is going in. And then don't forget your minus 3. All right, here we go. Distribute your 1/3. Guys, when you times something by 1/3, you're dividing by 3. So 1/3 times 3x is 1x. 3 divided by 3 is 1. 1/3 times positive 9, you're dividing 9 by 3. 9 divided by 3 is positive 3. And then bring down the minus 3. What happens to the plus 3 and the minus 3? They cancel, and you're left with just x. So there you have it. So we have proven that when you plug each function into the other, all operations cancel out, and you're just left with x, the original input, which means these are definitely inverses. They are undoing every operation that the other function is doing. So these are definitely inverses. So guys, on your homework tonight, your homework is going to be 6 questions on quizzes. It's just multiple choice. I'm going to give you 2 functions, and then it's either you pick inverses or you pick not inverses. Those are the only 2 options. All right, so it's pretty simple. All right, let's try B. Looks like the function's got a little bit more complicated. In part B, they gave us f of x equals 2x squared minus 1, so there's the important part. And then in G, they gave us g of x equals the square root of x plus 1 divided by 2. They want us to find out if these are inverses of each other. So to do that, we have to prove their compositions. So let's try f of g of x. Let's see what we get. Okay. All right, well, first x goes into g. He already lives there. Now we have to take the entire g of x function and plug it into f. All right, so that's going to be f of g of x was the square root of x plus 1 divided by 2. We got to plug that in to the other function. All right, here we go. So go to function f. It starts with a 2. Start rewriting. 2. This x comes out, and that big square root goes in. So now it's going to be the square root of x plus 1 divided by 2. And then since that x was squared, this is squared. And then don't forget to finish it with the minus 1. Excuse me. All right, we okay with that? That's kind of weird. All right, well, here we go, guys. PEMDAS. PEMDAS, they would do exponents first. So what happens when you square a square root? Guys, squaring something and square rooting something are inverse operations. They undo each other. So this square is going to undo that square root. And it's going to leave you with 2 times, now it's just x plus 1 divided by 2, and then the minus 1. The square and the square root cancel. You're just left with what's underneath it. All right, well, guys, now PEMDAS would say to multiply. Well, if I'm multiplying by 2, but then I'm also dividing by 2, that cancels each other out. So they're going to cancel, and it's going to leave you with x plus 1 and then minus 1. And then what happens to the plus 1 and the minus 1? They cancel. So I'm left with just x. So when I plug g into f, all operations cancel each other out. That's looking good for us. But remember, you can't just do one. You have to do the other composition as well. So let's go the other way and make sure all operations cancel again. So now we have to do g of f of x. Now we have to plug function f into g and see if everything cancels this way. All right, let's see. First x is going into f. He already lives there. We're good there. Now we have to take the entire f of x function and plug it into g. So that's going to be g of, who was f of x? 2x squared minus 1. So guys, this is our roadmap. We got to go to function g, and we got to plug 2x squared minus 1 in. So go to g. G starts with that huge square root. So give yourself that huge square root. All right? Then you get to an x. Take x out and plug 2x squared minus 1 in. So now it's going to be 2x squared minus 1, and then don't forget the plus 1. And then it's still all divided by 2. All right, so that's what it looks like when we have f living inside of g. Let's start cleaning up. Well, guys, what's going to happen to the minus 1 and the plus 1? They cancel. Now you're left with the square root of 2x squared divided by 2. Guys, 2 divided by 2, that cancels. So now you're left with the square root of x squared. And then what does the square root and the square do to each other? They cancel, and I'm left with just x. So yet again, all operations have canceled each other out. These are inverses. So I know it's annoying because I know you guys probably weren't a huge fan of the compositions in the last section, and now you have to do them all over again. All right, but that's how we can verify that two functions really will undo each other and become inverses. All right, let's go to part C. Let's see what happens in part C. What you eating?
Oh, quiche.
Was it quiche?
Yeah.
Did you make it?
I did not. It's from Strawberry.
Oh,
I love quiche.
I do too.
I don't make a good one, so that's why I just buy it.
Yeah. All right, hang in, guys. We're almost done. So look at example C. Now we're given the function f of x equals 1/2 x plus 5, and we're given g of x equals 2x plus 5. Let's see if these are inverses. So I'm going to go for f of g of x first. It does not matter though, you can find either composition. All right, so x goes into g, right? That already happened, right? We have this and we have that. Okay, so now we have to take the entire g of x function and plug it into function f. So that's going to be f of, who was g of x? G of x was 2x plus 5. All right, so this is what we're doing. We're going to f, and we're plugging 2x plus 5 in. So go to f and start rewriting. It starts with a 1/2, so give yourself a 1/2. Now you come to an x. That x is coming out, and 2x plus 5 is going in. And then don't forget about that plus 5. I don't know about you guys, but I'm already not liking what I'm seeing. If I distribute and get rid of my parentheses, half of 2x is 1x, and then half of 5 is 2.5. And then I still have a plus 5. Well, guys, nothing's canceling. They're going to add up as like terms, and I'm going to get x plus 7.5. Well, the operations didn't cancel out, which is great for us because it means they're not inverses. You don't even have to check the other composition. Once one of them doesn't work, they couldn't possibly be inverses. Because to be inverses, both compositions have to equal x. And since this one didn't, we don't even have to try the other one. So the answer is nope, not inverses. Which again is nice because it means less work for us. Okay? All right, I'm going to ask you guys to try this one. You guys find out in the last example if f of x and g of x can be called inverses. See if when you plug them into each other, can you get everything to cancel? Don't force stuff. Obviously, it's not always going to happen. I'm going to give you a head start. I'm going to double check the attendance. Are you guys okay? Yeah. And guys, just a reminder, if you join and I'm already teaching, you're supposed to put in the chat. There's been, I took attendance at the beginning and there are more people here now. Diego, Justin, Talisha, you guys were not here. You should have put in the chat.
My bad.
Thank you. Okay. All right, guys, if you look up here, this one was very, very similar to, I think, example B. But when I plugged G into F, I plugged x minus 1 over 2 in. My 2's canceled, and then my 1's canceled, and I'm left with just x. Then I did F going into G, so 2x plus 1 went into G. So then it became 2x plus 1 minus 1. My 1's canceled, and then my 2's canceled. So I'm left with just x. So these are definitely inverses. Okay? All right. So guys, you're going to have 6 questions tonight for homework on verifying inverses. So it's literally a quizzes assignment. You literally click on inverses as your answer, or you click on not inverses. It's like a 2-option multiple choice. So guys, I give you 3 attempts. You don't get it right on the first one, go back and pick the other one on the next attempt. All right? So that's how we can verify inverses. Can I get a thumbs up at home that we're okay? Okay, listen, I didn't make this homework due until Sunday night. So you have today, tomorrow, and Sunday to get this homework done on quizzes. Because Monday's gonna be a review, so that assignment will be due Monday night, and then Tuesday I'm gonna quiz you on inverses. And then we'll move on to the next section in chapter 6, okay? All right, I have your attendance, guys. So if you are home, I hope you have a great weekend, and I will see you guys on Monday.
Have a good week.